Welcome back. Let us go through the question first. Two inclined frictionless tracks, one gradual and the other steep, meet at A, from where two stones are allowed to slide down from rest, one on each track. Will the stones reach the bottom at the same time? Will they reach there with the same speed? Explain. Given theta 1 equals 30 degree, theta equals 60 degree, and h equals 10 meter. What are the speeds and times taken by the two stones? The free body diagram of the track is shown in the figure below. So this is the stone. This is the weight mg acting over downwards, and this is the angle theta 1, right? So the cos component is this and the sine component is this. Likewise, we can draw the free body diagram of this stone here as well. The weight is acting downwards, which is given by mg. This is theta 2, so the cos component is this mg cos theta 2, and this is the sine component, which is mg sine theta 2. And the reaction 1 is along this direction, r1. It is represented by r1, and r2 is represented here for this particular stone. Using the law of conservation of energy, we have a half mv1 square equals half mv2 square, which gives us v1 equals v2. Hence, both stones will reach the bottom of with the same speed. For stone 1, we can write F equals mg sine theta 1, or A1 is given by g sine theta 1. For stone 2, we have A2 equals g sine theta 2. Also, using the equation of motion, V equals U plus AT. T is equal to V by A. It is given that theta 2 is greater than theta 1, or A2 is greater than A1. Thus, T1 is greater than T2. Hence, the stone traveling on the steep plane will reach before. For finding the speed and time, we can use the conservation of energy. So mgh equals half mv square. V equals root over of 2gh. If we put in the values of g and h over here, we get the v to be 14 meter per second. And the time is given by t1 equals v by a1, which is again equals to 14 divided by 9.8 into sine 30, which gives us 2.86 seconds. And t2 is given by v by a2, which gives us 1.65 second.